Like my prediction is that, on this front, is that Optimus will be the biggest product of all time by far. Nothing will even be close.
Elon Musk has surprised the world many times, but few products have generated as much anticipation as Tesla's humanoid robot, especially the latest version, Optimus V3. With plans to produce thousands of units by the end of 2025 and a goal of reaching 1 million robots per year within the next 4 years, the moment when consumers can own this robot is no longer far off. So when will Optimus V3 actually reach users? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What are the latest updates Tesla has made to the Optimus V3? Recently, Elon Musk stirred up the tech community with a cryptic post accompanied by a short video showing Tesla's latest humanoid robot, Optimus V3, operating in a real-world environment. While the design of Optimus Gen 3 has been significantly simplified, it is the V3 version that has captured the most attention, with expectations that it will mark the next major leap in household robotics. Along with Musk's public call for collaboration directed at engineers working on Optimus, the video generated an intense wave of excitement, especially among tech enthusiasts and busy families seeking automation solutions for tasks like cooking, cleaning, and childcare. Based on Tesla's recent official announcements and viral posts on social media, there are increasing signs that Optimus V3 could spark a revolution in domestic life, turning the robot from a mere tool into a sophisticated multitasking companion. While Optimus Gen 2 once amazed the public with skills like dancing, boiling eggs, and expressive motions, the upcoming upgrade goes even further, now capable of vacuuming, stirring food, and interacting with household appliances. Elon Musk has described Optimus as a versatile companion.
So it can be a teacher, babysit your kids, it can walk your dog, mow your lawn, get the groceries, just be your friend, serve drinks. Whatever you can think of, it will do.
During Tesla's Q1 2025 earnings call on April 20th, Musk confirmed plans to produce thousands of Optimus units by year-end, aiming for 1 million robots per year within 4 years, a sign of Tesla's bold vision to mainstream humanoid robots on a global scale. Notably, V3 will integrate the Grok voice assistant from X.AI, allowing users to personalize the robot's voice, personality, and communication style, to the point where it can sense emotions or needs simply from behavior and expressions. From a technical machine, Optimus is gradually evolving into a vibrant member of the family, a helper, a friend, and a new symbol of full automation in daily life. In addition, recent feedback from Elon Musk has further raised expectations as he revealed that Optimus V3 will support multiple languages, communicate naturally, and learn from online videos. This was confirmed by Tesla engineer Milan Kovac, indicating that the robot can fully understand context and respond intelligently, such as navigating messy rooms or customizing hygiene routines to individual users. The ability to learn quickly from videos, from taking out the trash to cooking meals, vastly expands its range of use beyond any other consumer robot on the market. On tech forums, 2 topics are drawing major attention: the integration of Grok and the mass production target for late 2026. Both have fueled expectations that Optimus V3 may become a mainstream product priced around $20,000, a highly attractive figure for a robot capable of handling housework, cooking, watering plants, and more. Unlike current robots that only do one task, Optimus is designed for all-around performance in household settings. Musk insists that the goal is not just to use the robot in factories, but in every home, every household. He believes its exceptional efficiency will make people want to own one, or even several. In the latest video, Optimus performs a variety of specific tasks: picking up a trash bag, opening the lid, placing it in the bin, wiping tables, tearing paper towels, stirring pots, vacuuming, opening cabinets, and pulling curtains. Previously, it had also been seen folding clothes, watering plants, pouring drinks, checking inventory, opening car trunks, playing with kids, dancing with families, and tidying the kitchen. These abilities prove that this is no longer a distant future concept. It's now a real product, a smart device equipped with all the essential functions for the modern home. What's astonishing is that Tesla has achieved all of this in less than 2 years. As of now, Optimus can clean an entire home with just voice commands or even gestures and facial expressions, especially useful for users with communication challenges. You don't need to say much. A simple pointing gesture and the robot understands and acts. Unlike humans, Optimus doesn't need brakes. The Gen 1 model came with a 52-volt, 2.3 kilowatt-hour battery, allowing long-term operation without frequent charging. While it's unclear if the Gen 2 battery was upgraded, its weight has dropped to 138 pounds, promising even better energy efficiency. Optimus can carry up to 45 pounds without performance loss. Its hands, with 22 degrees of freedom, allow it to handle tools, operate vacuums, or prepare breakfast in seconds, and then clean up after itself. Thanks to continuous learning, each use makes it smarter. Additionally, it can perform outdoor tasks like trimming trees, watering plants, and fertilizing gardens. Musk once said Optimus could thread a needle, a clear testament to its precision and dexterity. Beyond chores, the robot also acts as a home tutor, reading books, helping with homework, and offering information to the elderly. In healthcare, it supports the elderly with walking, eating, bathing, and managing conditions like Alzheimer's by reminding them to take medications and remembering key events. Moreover, Optimus handles DIY tasks like changing light bulbs, fixing sockets, and alerting users to unusual incidents. Clearly, this isn't just a robot, it's a monumental step forward in humanity's journey to automate every aspect of life. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. What are the key differences between Optimus V3 and Gen 3? Tesla's Optimus V3 represents a significant leap forward compared to the previous Gen 3 version. No longer just a prototype under testing, the new Optimus has become a fully functional humanoid robot, capable of walking, navigating, carrying loads, and performing tasks in real-world environments with remarkable smoothness and intelligence. In a recent demonstration, the robot was seen freely moving around Tesla's 4680 battery factory in Texas, without any remote control or human guidance. It easily avoided people and obstacles, displaying agility and high spatial awareness, far beyond the rigid movements typically associated with robots. With this level of autonomy, Optimus is not limited to factories but can also operate in homes, stores, or even public streets. One of Optimus V3's most groundbreaking features is its ability to build a 3D map of its surroundings using video input, similar to Tesla's self-driving car technology. This allows the robot to recognize humans, objects, and obstacles to navigate accurately. Even more impressively, mapping data collected by one Optimus can be shared with others, enabling the entire fleet to learn and improve simultaneously, a practical application of swarm intelligence. Another key advancement is its highly capable hands. Optimus V3 is equipped with robotic hands featuring 22 degrees of freedom, nearly equivalent to the human hand and double that of the previous version. The hands are strong enough to lift a 25-pound, 4,680 battery tray with just its fingertips, yet delicate enough to hold an egg without breaking it, thread a needle, or even play the piano. Inside the hand structure is a newly designed tendon system that replaces the previous spring mechanism. Each finger has 4 tendons and upgraded tactile sensors, allowing for more precise and nuanced movements. Optimus now also features autonomous charging. It can locate the nearest charging station, use its rear camera to align itself, and connect without any human intervention. Furthermore, Optimus robots can collaborate. If one needs a tool and another is closer, they can coordinate to assist each other. This represents a new level of autonomy and interactivity, opening doors to highly practical use cases. Optimus is now capable of handling stairs, uneven terrain, and tight spaces, challenges that even many advanced robots still struggle with. At the recent Tesla Robot Day, 50 Optimus units participated in welcoming guests, serving food and drinks, marking the largest real-time robot demonstration ever held at a live event. While some voice response functions were still remotely operated, this is common at this development stage. Tesla aimed to make a strong impression, and they certainly succeeded. Elon Musk revealed that Tesla plans to deploy thousands of Optimus units in factories starting next year, with limited availability to external customers by 2026. Currently, the company is focused on refining the robot's dexterity, particularly the hands, which are critical to making Optimus useful in daily life. In the near future, you may see Optimus assisting the elderly, caring for children, mowing lawns, cleaning kitchens, or even walking pets. It is no longer just a factory machine, but a new household member, a companion in everyday life. Musk also believes Optimus will replace humans in repetitive or hazardous jobs, tasks people don't want to do. While the initial price of the robot may be relatively high, Tesla expects costs to decline over time as production scales up, similar to what happened with electric vehicles. The target price is around $30,000. What sets it apart is that, unlike a car that sits idle in a garage, the robot can work continuously and even generate economic value for its owner. In the long term, Tesla aims to manufacture between 1 to 2 billion Optimus units globally. Half of these would serve in households, while the other half would operate in industrial sectors like logistics, factories, restaurants, and healthcare. The key question remains: would you be willing to entrust your pet, child, or elderly family member to a robot like Optimus? Think carefully and share your thoughts. When will consumers be able to buy the Tesla Optimus robot? This question is gaining significant attention as Tesla continues to make remarkable progress with its humanoid robot. Recently, Musk mentioned a new version called Optimus 53 in a June 2025 post, revealing important upgrades in mobility and task handling. Tesla's lead engineer, Milan Kovac, confirmed that the next-generation Optimus would integrate the Grok AI assistant, developed by X.AI, enabling the robot to interact through voice, learn languages, and even watch videos to acquire skills. This opens the door to a future where robots can seamlessly integrate into family life and interact more naturally and intelligently with humans. Although Optimus is still in a learning phase, Musk says that within just 2 to 3 years, it could perform household tasks like a professional assistant. Uniquely, Tesla is updating Optimus's software and learning algorithms nearly every day, far more frequently than typical electronics like smartphones or TVs. This allows the robot to learn quickly, continuously adapt, and become increasingly sophisticated. As of mid-2025, Tesla has already deployed over 100 Optimus robots for trial operations in its factories, especially at Giga, Texas. Musk confirmed that the robot would begin taking on real-world factory tasks by the end of this year and could be made available to external customers as early as late 2025. In parallel, Tesla plans to unveil the high-end Optimus Gen 3 this November, featuring hands with 22 degrees of freedom, 1.5x faster processing than Gen 2, and a refined AI brain for superior autonomy. However, Musk also admitted that mass-producing Optimus is still a major challenge. He noted that creating a sleek, functional robot is not enough. The key lies in designing something that can be manufactured at scale and at low cost. Tesla faced similar issues with the Cybertruck, where its bold design delayed production by over 2 years. As a result, Gen 3 of Optimus has been re-engineered for manufacturability, simplifying its structure to reduce costs and scale production more rapidly. Initially, Musk suggested that Optimus might cost around $20,000, comparable to an average car. However, many analysts believe the realistic price in the early phase could be much higher.
Assuming things go well, we'll 10x that output next year. So we'll aim to do maybe 50 to 100,000 humanoid robots next year.
Elon Musk stated. But to turn that massive number into reality, Tesla can't rely on a one-size-fits-all design for every environment. A robot that cleans floors cannot be the same as one working on a factory line or patrolling a construction site. So what must Tesla adjust to ensure Optimus truly fits each specific environment? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What makes each working environment require a different robot design? Tesla Bot will not achieve optimal performance if only a single design is used for all environments, whether at home, in factories, or outdoors. The nature of work in each environment demands completely different materials, structures, and load-bearing capacities. In factories, robots must perform tasks like lifting 44 to 66 pounds components, operating continuously for 8 to 12 hours per day, traversing concrete floors, and withstanding impacts on assembly lines. This requires Tesla to use a chassis made of 7000 series aluminum alloy or stainless steel, with tensile strength above 72,500 pounds per square inch. In addition, the joints must deliver a torque of at least 44 to 59 foot-pounds in the shoulders and legs, and the outer shell must resist oil contamination and high temperatures. By contrast, in home environments, tasks are much lighter: folding laundry, opening doors, carrying a glass of water, or assisting the elderly to stand up. For these tasks, using lightweight materials like PA66 or ABS engineering plastics combined with composites helps reduce the robot's weight below 88 pounds, while also minimizing the risk of injury upon contact. If Tesla does not differentiate configurations between environments and uses the same design for all purposes, the robot may be overbuilt for simple tasks or underpowered for heavy ones, leading to lower efficiency, higher energy use, and increased risk of damage. Working environments also strongly affect the drivetrain and battery system. Actuators are the most power-hungry components in humanoid robots. In factories, robots require BLDC servo motors with 0.4 to 0.67 horsepower per joint to perform forceful, precise movements. At home, robots can rely on smaller motors rated at 0.1 to 0.16 horsepower, enough for gentle manipulation and agile motion in tight spaces. Using overly powerful motors for light tasks reduces electrical efficiency and unnecessarily increases battery capacity, weight, and cost. For example, factory robots need batteries of 1.6 to 2.0 kilowatt-hours to operate 8 hours under heavy load, while home-use robots only need about 0.8 to 1.1 kilowatt-hours. Not only hardware but sensors and control software must also adapt to the intended environment. In factories, robots require long-range LiDAR, 130 to 200 feet, to avoid machines, as well as high-precision force sensors in the hands with plus or minus 0.22 pounds, sensitivity to handle heavy objects. Meanwhile, home robots only need short-range proximity sensors, standard RGB cameras, and microphones for voice command recognition. Factory navigation focuses on device alignment and repeating action cycles with high accuracy, whereas home robots must analyze user behavior, avoid pets, and detect children. When a robot is designed specifically for its environment, production costs can be greatly optimized. Eliminating unnecessary modules reduces weight, simplifies the structure, and increases reliability. Assuming each functional module accounts for 5% of the total cost, removing 4 to 6 modules could reduce manufacturing costs by 20 to 30%. Given Tesla's target price of $15,000 to $20,000 per unit, this strategy could bring the cost down to around $12,000 or less, making large-scale commercialization viable. Simpler designs also make robots easier to repair, less prone to mechanical failure, and easier to maintain. All these factors show that developing specialized versions like Optimus Home, Optimus Factory, and Optimus Outdoor is essential for the successful global rollout of Tesla Bot. This is not merely a product strategy, but a technical necessity to ensure operational performance, safety, and cost efficiency. While versions can still share common software, FSD chips, and Grok AI systems, the mechanical design, actuators, and sensors must be tailored to specific usage environments to ensure that each robot performs reliably and economically. Additionally, categorizing Tesla Bot by use case opens the door for a modular production strategy, where core components can be flexibly assembled depending on the robot's purpose. For instance, the same central body and AI system could serve both home and outdoor versions, while the arms, sensors, and drivetrains would differ. With this approach, Tesla could replicate its success with the Model 3 and Model Y platform, where over 70% of components are shared, reducing cost and boosting manufacturing speed. This modular design fits well into Tesla's automated production lines at Giga Texas, allowing version customization by swapping a few key components during final assembly. This could be the key for Tesla to scale up production rapidly while maintaining tight control over quality and cost, especially critical if Elon Musk intends to manufacture millions of Optimus units each year as stated. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. How does specialized Optimus Gen 3 design help reduce costs? As Tesla sets its sights on producing millions of Optimus robots annually, cost is no longer a secondary factor. It becomes the key determinant of commercial viability. With the projected price of humanoid robots ranging from $15,000 to $20,000, any savings in manufacturing, configuration, or maintenance could translate into billions of dollars when scaled. Designing a single all-purpose version for every environment would force Tesla to include the most powerful components in a single unit, resulting in excess hardware, unnecessary weight, and overbuilt systems for each user segment. In contrast, dividing the product line into specialized variants, Optimus Home, Optimus Factory, and Optimus Outdoor, can significantly reduce costs across 3 levels: hardware, mass production, and operational maintenance. Starting with hardware costs, an all-purpose robot would need to combine industrial-grade structural frames for factory use, infrared and GPS modules for outdoor use, and sophisticated AI communication systems and fine actuators for domestic use. As a result, component costs could increase by 30 to 50% compared to optimized configurations. Assuming each unnecessary module contributes around 5% of total production cost, eliminating 4 to 6 modules could cut costs by 20 to 30%. For example, an Optimus Home would not require a high-load frame or active cool-in system. Just these 2 modules alone could save $1,500 to $2,000 per unit. Similarly, the Optimus Outdoor version would not need advanced NLP or soft finger actuators designed for home environments, further eliminating 5 to 8% in avoidable costs. In terms of mass production costs, specialized variants simplify the assembly line. Each robot type only requires predefined modules without the need to test every redundant system. Given that a single robot may go through 600 to 800 assembly steps and 20% of those steps are specific to a particular environment, separating variants could reduce assembly time from 3 to 4 hours per unit to 2 to 3 hours. This shortens workloads for production robots and technicians alike. Not only does this reduce labor costs, but it also lowers the inventory of spare components, one of the biggest hidden costs in large-scale manufacturing. Based on Tesla's Gigafactory model, a single minute of downtime due to misconfigured parts can cost tens of thousands of dollars. Therefore, minimizing complexity per version directly improves operational efficiency. When it comes to maintenance and repair costs, specialized robots are easier to diagnose and service. An Optimus Home unit can be optimized with only 12 to 14 key modules, compared to 18 to 20 in a multi-purpose robot, making repairs simpler and requiring less technician training. Furthermore, components are not overused or misapplied, so they last longer. For instance, factory-grade actuators are designed for high power, but if installed in a home-use robot, they remain underutilized, leading to wasted energy and lower overall efficiency. In contrast, lightweight actuators designed for Optimus Home can last twice as long when used at appropriate loads. From a logistics and operations standpoint, managing a uniform ecosystem of robots tailored for different purposes enables easier selection for customers and easier deployment for businesses. Suppose a company uses 100 Optimus Factory units and a household uses 1 Optimus Home. If both versions shared the same structure, diagnosing a failure would take twice as long due to unrelated variables. Specialized designs allow the diagnostic software to focus precisely, reducing repair time from 5 hours to 2 hours, and cutting operating costs by 20 to 40%, depending on deployment scale. Ultimately, product cost is not just about purchase price, it's also about practical utility. A $15,000 robot that completes 90% of its design tasks will always be more economical than an $18,000 robot that performs poorly due to improper configuration. Environment-specific optimization increases return on investment per dollar spent, which is especially important as Tesla moves toward hourly or monthly leasing of Tesla bots. An optimized Optimus home could cost users less than $2 per hour, compared to $3 to $4 per hour if a general-purpose robot were used instead. In conclusion, dividing Tesla bot into specialized variants is not only a smart design strategy, but the only viable way to control lifecycle costs, from development and manufacturing to operation and maintenance. As Tesla aims to deliver robots to both enterprises and households on a multi-million unit scale, specialization is the most practical path to lowering prices, improving efficiency, reducing failure rates, and accelerating the adoption of humanoid robots worldwide. What does Tesla need to do to produce and deploy millions of Optimus robots globally, efficiently? As Tesla sets its goal of producing millions of Optimus units annually, the challenge is not just about building a product, but about scaling deployment, accelerating global expansion, and ensuring synchronized operations worldwide. If Tesla tries to use a single robot model for all purposes, it would not only create a technical burden, but also cause bottlenecks in manufacturing, distribution, training, and maintenance at scale. On the other hand, by dividing Optimus into product lines like Optimus Home, Factory, and Outdoor, Tesla can build dedicated production lines, optimized for specific configurations, enabling faster production and a more controlled, phased market rollout. From a manufacturing perspective, each specialized version allows for a simpler and more stable assembly line. For example, if Optimus Home only requires 12 core modules, instead of the 20 found in a general-purpose unit, the production line becomes shorter, requires fewer inspection steps, and faces lower assembly error risks. Assuming each module requires 10 minutes for quality inspection, eliminating 6 to 8 modules could reduce average production time per robot from 4 hours to under 3 hours. This is particularly critical for Tesla, a company already experienced in high-speed automated EV manufacturing at its gigafactories. When applied to robots, a similar model will be even more effective if products are standardized by version. Moreover, breaking the product into versions allows Tesla to allocate production resources more efficiently across its global factories. For instance, Optimus Home, compact and consumer-oriented, can be produced at Giga Mexico or Giga Berlin, closer to key consumer markets in Europe and Latin America. Meanwhile, Optimus Factory can be produced mainly at Giga Texas, where Tesla is already trialing the robot internally on automotive production lines. This minimizes the need for long-distance shipping, saving logistics costs, and shortening the time from production to delivery. A bulky, over-integrated, all-purpose product would force centralized production in just a few locations, causing supply bottlenecks when demand spikes. Beyond manufacturing, AI training and software updates can also be accelerated when products are divided by usage purpose. With each Optimus version assigned a clear task set, industrial operation, household support, or outdoor mobility. Training data can be grouped, narrowed in scope, and optimized faster. For example, the Optimus Home group only needs to focus on indoor environments like kitchens, living rooms, or bathrooms, allowing AI to quickly learn common situations and improve interaction accuracy. In contrast, a multi-purpose robot that must simultaneously learn from outdoor videos, industrial sites, and home settings would process more slowly, consume more dojo resources, and fragment the training algorithms. Segmented product development is the most effective way to train AI models quickly, efficiently, and with focus. From a commercial rollout standpoint, environment-optimized variants allow Tesla to distribute robots in phases across specific regional markets, instead of releasing a one-size-fits-all product that would require heavy customization to meet local demands. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.